Hello, welcome to this ROS question and answer tutorial. My name is Marco Arruda, and today I'm going to show how we can solve the problem of this user. First of all, let's try to understand what is happening here. And the user wants to subscribe to a topic, which is a fake AR publisher, and resend the post, so he's subscribing to a post message, and he wants to provide the post information through a service, okay? He has a script that is subscribing to this kind of message, and at the same time acts like a server for a service called LocalizePart. Okay, great, so let's try to reproduce the problem and find out why it's not behaving as expected. In order to do that, I'm going to use the RDS, ROS Development Studio, provided by Deconstruct. If you don't have an account yet, you can create a new one and use the RDS for free, just following the link in the description of this video. So let's start creating a new project here. I'm gonna call it Service Debug. This is a private project because I don't want to share with others. Okay, great. We have a new project here. Let's open it and wait a few seconds until we have our ROS development environment ready to be used. So at the center of my screen I have my IDE because I have configured like this. You can change the configuration using this button here. The terminal, on the left side my Python notebook. I'm not going to use this time, so let's hide it. And if you want to simulate some robots or develop an application for a robot, you can choose one of them right here. Okay, so let's get back to the problem of the user. First of all, let's start creating a new package. So catkin create package. I'm gonna call it my package. We are using Python, so it depends on ROS.py. Let's use also some messages from standard messages and geometry messages. And we want also to create a custom server. So we have to create a new kind of message. Because of that, we have to include also the message generation. Okay, that's it. Here we have our new package. Let's start creating our new service message. The name of the message is LocalizePart. That's the definition of the message. Let's create here LocalizePart.srv. That's the ROS convention. So the user hasn't described his message, but he wants to return the position and orientation. So using pose, the pose kind. As a request, I'm gonna use just an empty message from standard messages. So that's the request. 3 hyphens here, ROS, that's a ROS convention, and let's return a pose message. So geometry messages, pose, my variable is called pose. Okay, great. And we have also to configure our CMake list file. So this is a make file, let's find it here. And let's configure it. So in order to generate our new message, add service files, we have to uncomment this instruction right here and put the name of the file, which is LocalizePart. Okay, so LocalizePart, and our message depends on other libraries, other messages. So we have to uncomment here generate messages, dependencies, geometry messages, and standard messages. Okay. So for instance, that's it. Let's compile our workspace in order to generate the new message. First time it may take a while, and that's it. Our message was generated, and let's source our environment again, our workspace, because we have new libraries available. And let's check our new service message. So ROS service list grep localize, and here it is, my package LocalizePart, ROS service, show my package LocalizePart. So we have the request as an empty message, and it's returning, it should return a pose message, okay? Position and orientation. So let's go to the code. We have to create a folder. Let's create a folder here just to keep it organized. Call it scripts and create a file here. So that's our server, so server.py. Let's copy and paste the code of the user. Okay, it's not indented, so I don't want to waste your time here on the video, so I have a template here where I have formatted the code, and this is what we have. So first of all, let's start cleaning this up. The user is importing the string library here, but it's not being used, so let's remove it. And also the integer 16 is not being used. There is another custom message here called message1, also not being used, so let's remove it. LocalizePart, that one is being used right here, but the name of the package is different from mine. My package is called myPackage, so let's rename it myPackage, import LocalizePart, and the user is subscribing this AR marker. Okay, we don't have this message, and we're not using this random library, so let's remove it. Let's also remove some comments here and debug messages, just to have a best view of the code. Okay, now it's easier to understand. So we start here calling this function vision node service server 2. We are initializing our node, myworkcell node, and subscribing to this message, AR pose marker, that's the name of the topic, and the kind of the message, and assigning to this callback to do something with this message. Okay, so they are putting the value of the message to this variable called receivePose, and then the user is creating the server, which is this kind of server, LocalizePart, and it provides the pose that comes from the subscriber through the server, okay? And the callback of the server is this function here, handle service 2. Okay, so first of all, we want to debug a problem with the server. So we have a problem here because we don't have this kind of message. The user hasn't posted the kind of message. So let's just simulate it. Okay, what we need is a pose. So we don't have this a publisher, neither this kind of message. Let's remove it, and also the callback of the subscriber. And we want to only to return a message pose using the server. So let's define here received pose equals to pose, which comes from geometry message. So we have to import it here from geometry messages, message import pose. Okay. We are not using anymore this AR marker. Let's remove it because now we are not subscribing. Remember, we are just simulating the value we have. Let's fill some values here. So geometry messages, we have position, X, Y, and Z, and orientation, which is a quaternion orientation. Also X, Y, Z, and W. Let's put it 1 and 3, 5, and 7 for the position, just to have some value. And finally, here we have received pose. We are importing here the object pose. We are importing our new message, LocalizePart, filling the values, defining the callback of the server and returning the received pose. But here we have the object received pose, which is already a pose, so we don't have this attribute here, pose. Let's remove it. Okay, so we have received pose. Our main function, which is initializing our node, creating a service. Okay, assigning the callback here. The name of the service, the kind of the service, the one we have just created, ROS by spin, great, and calling the main message. So I think that's it. Let's try to run it and see what happens. So I did it already. Let's try here. ROS run my package, the name of the executable, server. Okay, so we have something running. We don't have any log messages here. So let's check our node. We can create a new terminal here using this button. Let's put it smaller. ROS node list. So here we have our node. ROS service list. Here we have our service. LocalizePart. So let's try to call it and see what happens. ROS service call. LocalizePart. Tab. Okay. We have to source the workspace because we have new messages here. ROS service call LocalizePart. An empty message, and here is the error the user has reported on the forum. So service LocalizePart responded with an error processing request, global name LocalizePartResponse is not defined. So the truth is that when you create a new service message, ROS generates 3 new classes for you. Okay, one is for the definition of the service, LocalizePart, which it has the same name of the service file you have just created, so LocalizePart, and a class for the definition of the service, LocalizePart, and also you have LocalizePartResponse, which is the object that is being returned. Okay, so the problem is that the user was not importing the LocalizePartResponse here at the beginning of the file. So we are working with Python. We don't have to compile anything. Let's just run the node again. So we have the node running. And let's call the service again. And here we have the values. Okay, we have a pose message, position 3, 5, and 7, and the orientation, a quaternion, and that's it. It was quite simple to solve, but sometimes we can get tricked by ROS conventions. I hope it can help you. If you like this kind of video, don't forget to subscribe to our channel and have a new video about ROS every day. See you!